Okay, well, but when Steve and Bill asked me to do this presentation, I was quite happy to do it. Initially, it was fine. It was, the Hailing Island seminar, Soldermask manufacturer in the UK, history of maybe. And then as we got closer, I got a little bit worried because I wasn't quite sure whether it was going to be the UK or not. England, Wales, well, and Northern Ireland, obviously. But finally, we got there. So we're back as Soldermask manufacturer in the UK, thankfully. It's hard to do this as a Soldermask manufacturer in the UK. It's hard to do this without it being a little bit like a commercial for Electra. Some of you will know us, some of you won't. But to blow our trumpet a little bit, as I think Steve alluded, we've been around now for 30 years. We had our 30th anniversary this year. The company was founded in 1984. We're privately owned. We're not owned by a large organisation. There are about 6 shareholders in total. 3 out of 4 of the original founders, one of which is myself, are still involved in the business actively. And we are a UK-based R&D and manufacturing organisation. But we do have export-orientated sales. Somewhere in the region of 90% of our sales are exported. And that percentage has gone up steadily. It started at around 75%. Partly because the UK industry market has shrunk, but obviously we've been fairly focused on that part of the market. And we serve both the PCB and the wafer level packaging industries, and increasingly that wafer level packaging side of things, which is the more high tech possibly end of the business, is growing and now forms somewhere between 25 and 30% of our overall business. So we've got a number of core activities. We can break them down. I'm not sure. Yeah. So the original one, conventional printed circuit board materials. There are a number of threads here. We've got conventional LPI. Most people have heard about that. But also increasingly now we're looking at LED and laser image systems. Also the super white solder masks, which are used on boards which have LED lights on them. And more on those later. 100% solids, photoimage etch resists, photoresist for flexible substrates, peelable masks, and again, increasingly now, inkjet, legend, and also now Soldermasks. We develop all our own resin, develop a number of our key resins ourselves, and some of these are used in our own products, some of these we sell on to companies who are making LCD and flat panel displays. So another string to our bow. The wafer chip scale packaging materials, there's a couple of them. We have some low temperature curing by their points of reference anyway, photopolymer dielectrics, not dissimilar to solder masks, but used in quite different ways. And we also have some dielectric and plating resists, which are based on some fairly unusual silicon resins, as opposed to the usual epoxy types. And we've had, ever since we started, our range of polymer thick film materials. So all of these really go into electronic applications. And at our manufacturing site, it is our central manufacturing facility. It's our only manufacturing facility. It's where we do all of our R&D. And we do a lot of customer-specific development as well. Talking to customers, they tell us what they want. And as someone once said to us, we have a hard time saying no. So we'll have a go at most things. About 25% of our business, of our people are based and used in our R&D activities. So once again, this LDI and LED solder mask, we're looking at reducing the amount of energy that's required to keep the exposure times down. Rapid exposure solder mask, this is an ongoing project. We have some patented technology which we're hoping to utilise. It's not proving to be easy, if I'm honest, but we keep cracking on at it. These white solder masks, inkjet inks for etch resists and solder masks. This high-speed etch placing resists for use with a chemical system, the Rainbow system, which we've heard from before. We've also been involved with polymer membranes. Again, utilising our skills as UV curing people. We got involved with a project, TSP funded project, to develop membranes for using hydrogen fuel cells. It made progress with all these, as with all these things. There's still a lot more work to do. These wafer level products, and we've also made some very obscure coloured solder masks recently, as a direct result of inquiries from Stacey. But at the heart of it all, you know, our core values are that we want to produce reliable products, new, innovative products. We give good technical support all over the world, either directly from the UK or by training our distributors, wherever they may be. And we do that by making technical visits, running process audits to our customers. We pick our distributors and our sales partners in overseas territories very carefully, and we try and tailor our products to their local marketplaces. Those of you that have never been in an ink factory may be quite surprised as to what goes on. So I thought I'd just share some photos of what we do. This is one of our manufacturing areas, actually, for some of the wafer level packaging products. We don't make those in anything like the volumes that we do some of the other products, but with some of them we have to modify the resins even that we buy in. So we use this process here where we're taking out the solvent that the material is supplied in, replacing it with a more suitable solvent. This is a general view of our lab. This has built up over the last 10 or 15 years. But we have a general work area. We've got QC at this end. Factory is out the back downstairs. I'll see some pictures of that later. And then we've got the general tech service and development areas within each operator or each technician, chemist has his own working area. We have a fairly well equipped, although not always with the newest equipment, analytical lab. This device here is a GPC. We use it for measuring the molecular weight and the molecular weight distributions of the resins that we use, both in terms of development and goods inwards QC. You'll recognise some of the other bits and pieces here, presses and microsections for tech service. Along here we have a number of microscopes. We've got a UV spectrometer which we use for measuring the UV absorption or the light absorption, generally it's UV, of some of our coatings, particularly with different photoinitiators, so we can help to pick the right initiator for the process that we're producing the product for. And there's an infrared spectrometer buried in there as well. This device is a DSC, or differential scaling calorimeter. It enables us to determine exactly how well cured or how much cure our products need in the development stage, and then how well cured they've been by the customer if they complain that it doesn't stick to the boards. We can determine whether it's 40%, 60%, 80% cured, and advise the customer accordingly. This is another close-up of the QC area, or part of the QC area. Again, so we have another infrared spectrometer. We use that for matching production samples with retained samples. The software inside it tells us whether we have more than an 85% match, which is our key. And as one of our, actually he's no longer with us unfortunately, but he's making one of the viscosity measurements that we make routinely with every batch that we produce. A lot of the wafer level packaging materials are much more sensitive to ambient light. So when we started to produce more of those, we decided we needed to segregate off an area which we operated under yellow light, which for an ink manufacturer is relatively unusual. I mean, board companies have done it all the time, but we segregated out the area, and the equipment that's used for manufacturing those products gets put into that area. This device here is an HPLC, which is used for measuring contaminants, various ovens and things, as you would expect. But there's another fairly bog standard UV curing machine. But it means that we can keep this area much cleaner than a standard, the normal ink manufacturing area as well, so we don't have to keep running in and out to use standard lab equipment. I'm quite sure what that was in there. I think it was a roughness tester, but quite why the photograph was taken with a cover on it, I'm not sure. This is another one of the viscometers that we use for products which are being produced in that area. This one's a Harker, and this device here is a centrifuge which we can use for actually for dispersion, believe it or not, of some of the products. So that's just briefly our working environment. To bring it back to the, if you like, the headline was Soldermask. So what's it for, first of all? Well, in the beginning, if we're talking about the history, it's fairly simple. It was just there to enable mass soldering, wave soldering, rather than having to hand solder everything, and it prevented solder shorts under the components. No, it still doesn't work. It was applied by screen printing only, and some of you will probably remember the old two-component epoxy systems, EM10, EM5 was our product. Coates Brothers had a product, XZ15, XZ17, mixed at the point of use, and they had a relatively short shelf life. They were superseded in the early 80s, really, by UV curing solder masks. Most of them were single component. We did produce a two-component as well. But they were really aimed at the high-speed printing end. And when Philips had their plant up at Croydon, they were producing printing and curing in excess of 600 panels an hour on a fully automatic printing line. But they could only do that using UV curing solder masks. But as time went on, we all know the smaller, lighter, faster, blah, blah, blah. And it became, unfortunately, the fact that you couldn't screen print accurately enough if you were trying to register on the board. So the first photoimageable solder masks started to appear. Prober 52, which came from Sieber Geigy, was a three-component system, and it was really only for curtain coat application. Coates and Sieber, and I was at the time working for Coates, argued long and hard and very expensively as to who came first, and made the patent lawyers very rich. But eventually they reached some kind of agreement, and Coates Image Cure product, which was a single component product, came out. Initially for curtain coating as well, but they did change that and produce a screen printing version as well. And then we came along and produced the first two-component liquid photoimageable solder mask in 1987. And that was really the start of our development program. That gave us the advantages of the single pack system in terms of length of pot life. We had a 5-day pot life, but it gave us all the performance that was required, very similar in fact to the two-component epoxy-based systems. And it was in fact an epoxy-based system. The resins were based on modified epoxies and the hardeners were based on pure epoxies. So there were a number of products that sprung out of that as the market demand developed, because the solder mask is required to prevent corrosion to the underlying circuitry. It has to act as a plating resist for things like DNEG, immersion silver, immersion tin. It has to prevent the growth of metal whiskers under the coating under humid conditions. It has to insulate the substrate from debris and from moist and aggressive environments. It has to assist with component placement, making sure that the components line up. And it has to reflect light for LED backplanes. All the while, it has to be able to be applied by nearly every known method there is. It has to be impossible to overdry. It has to be cheap, obviously. It has to be fast exposing using any imaging process, whether that be LED, LED, laser, metal halide. It has to be easy to develop out of the small holes, the via holes, but it has to be able to coat large holes. Has to be cheap, obviously. Has to be rapid curing when you get to the end of the process. Has to resist all known chemical processes, whether they be plating, cleaning, and anything else that people want to throw at it. But it has to be easy to remove if you don't need it anymore. Has to be cheap. Has to be available in every colour and surface finish under the sun. Did I mention it had to be cheap? So there's a lot required now of well, it's not just one Soldermask formulation, it's many. And I tried to categorise these. We've had to change the way these products are categorised as time has gone on. So yes, we're talking about a Soldermask. Now we split them up into non-photodefinable resists and photodefinable resists. The non-photodefinable resists are the screen printable versions, whether they be UV or thermal cure. Really, I mean, there are a few people still using thermal curing solder masks, but not very many. Actually, I think they get used in the automotive industry, funnily enough. Customer that we have that produces power boards. And there's inkjet, obviously, where you're actually putting the ink down where you want it directly. Of the photodefinable resists, obviously the hot and sexy ones these days are the laser or the LED imaging systems. And then there's what would be the conventional now liquid photorenewable solder masks, which are exposed through a photo tool. So there are multiple application methods that are still used to apply these materials. Single-sided screen printing machines, double-sided screen printing machines, curtain coaters, another curtain coater. We were very strong at one point with the high-pressure, low-volume air spray systems. There's still some around, and they still do a great job with the boards where boards are suitable. And I think we were the number one supplier of solder masks for those machines at one point. Electrostatic spray was another one that was used, not very widely, but again, the solder masks for that had to be custom made so that they would work in that application. And then, with apologies to Viking, there's the inkjet, and we're throughout our history we've tried to work very closely with all equipment manufacturers. Again, because they're all different, they all have different requirements for product. We have done some work with Viking, and we continue to do so, and we are working with Microcraft as well. So I was going to talk in a little bit more detail about a couple of the newer products. The first one being our direct image solder mask. Again, we've optimised formulations now for, at the moment at least, two application methods, one being the spray system and one being the double-sided screen printing system. The key thing is a low energy requirement. You know, lasers develop or deliver energy fairly slowly. So in order to keep the exposure time down to a reasonable length of time, we need to be producing or using between 50 and 80 millijoules. By comparison, a conventional LPI will take anything from 300 to 600 millijoules. So it's quite a big ask. But that gives us an exposure time roughly between 35 and 50 seconds on an Orbotech machine. And a surface or a clear step of 10 or 11 on a Stufa step. And that makes sure there's no surface erosion or attack during the developing stage. Because obviously what we want is the surface finish to stay the same out of the developer as it was when it went in. And we still have to meet all of the resistant requirements of the different plating processes. We need to have a nice strong colour. It has to be halogen free. Interesting thing, I've mentioned this before when I've spoken, solder mask is green by and large, and etch resists are blue by and large. The reason for that is that when they first invented them, they were looking for some nice cheap pigments that were heat resistant and chemical resistant, and those pigments are phthalocyanine pigments. And the chlorinated one, the two pigments are chemically very similar, except that one contains chlorine, which is a halogen. And that was the one they chose for the solder mask, unfortunately. So everyone expects to see a nice green solder mask, but they don't want halogen in it. So there's been a lot of work over the years looking at blending colours, blues, yellows, finding halogen-free pigments, which will still withstand all the soldering operations and the chemical processes and be light stable. And you know, we're there now, but it wasn't easy. And we want a nice even appearance over all the tracks. We don't want bright edges, which is a thing which occurs, or which we resolve using rheology and control of rheology, thixotropy, to make sure the solder mask stays where it's put. What we end up with is some pretty good results. Not much in the way of undercut, and equally not much in the way of image growth. If we're trying to print a 50 micron dam, what we want is 50 microns at the bottom on the substrate interface, and we also want 50 as much as close as we can get at the top. What we don't want is 80 at the top and 30 at the bottom, which is what happens with less optimal products. These are some SEMs we had done of some product. You can see some pretty nice looking edges and well-defined edges around pads, tracks. And just one of the key things, and I didn't know whether to put this particular slide at the beginning or at the end, but one of the key things, and why there's so much work involved for us in developing products for lasers and LED exposure systems, is when you look at a conventional, for want of a better word, metal halide lamp, it produces this blue line, this here, a lot of different peaks at different wavelengths, different intensities. You know, there's one here about 365, that's the wavelength that everybody knows. There's one at about 405 somewhere here, which people have generally heard of. But there's something going on pretty much throughout the whole of the spectrum. When you start using a laser produces wavelength emission at 355 nanometers, pretty much bar none. I think it's plus or minus 2 nanometers. So if your photoresist, or in particular the photoinitiators in your photoresist, absorb over here somewhere, whereas that might be fine with a metal halide lamp, because there's still enough going on over here that'll give some degree of cure. It may not be as quick as it could be, but you know, there'll be some. There'll be absolutely nothing happens with a laser, because there is nothing out here. So we've had to do an awful lot of work tuning the absorption of the initiators to match the spectrum of the laser in the case of a system which is used for laser. LEDs, which are also now being used for direct imaging, produce light at a different wavelength. There are LEDs that will emit at 355, but they're not very powerful and they don't do they're not widely used. So they tend to use emissions around the 370 to 390, 375 to 395 nanometer, which is up here. And we have to use different photoinitiators now for those products to make sure that they match the emission spectra of the LED lamp. Some of the machinery manufacturers now are putting in 2 sets of lamps, so they'll have it at 375 and 395, which makes our lives a little bit easier. But again, it's one of those reasons why we have to work really closely with the manufacturer, machine manufacturer, so we understand what he's doing with his lamp system to make sure we can offer the right product for him. The other material which is quite a hot topic at the moment is the super white solder mask. This is used on the back planes of circuit boards that are going to have LEDs mounted on them. Conventional in the sense that, you know, we still got to tack dry it. It needs to dry pretty quickly. And bearing in mind it's going onto a high heat sink substrate, that can be a challenge. But from the functional point of view, it has to have a very high blocking power, we call it, which means that it covers up the colour of the copper and the laminate. And the reflectivity of it has to be tailored to suit the white LEDs. We don't want any discoloration or staining, which is not uncommon. I don't know how easy or how clear that is from where you're looking. this is a traditional white LPI that we've had for a long time. And this is the LED white. Now on my screen here, it's a pretty dramatic difference. I don't know if it shows up quite so well there, but you know, it gives a clue as to the degree of colour that we've had to change in colour we've had to achieve. And this is an example. This spectrum here is a combination of the emission from a white LED from the different processes, and then this is a spectrum of a white tile that we use as a standard, and these are the reflectance spectra of the two different inks, whether they've been screen printed or sprayed. So you can see the application method doesn't really make any difference. The reason that one is slightly above the other is that the screen printing product tends to be slightly matter, so it reflects overall slightly less than the spray. But it's as near flat as we can get it. We always get this dip here, but I've seen some where it's down here, or it just fades away to nothing, and that will cause a colour cast with the LED board. We also want to see no colour change during the soldering operation, and here, you know, again, you can see there's already a difference here, but as it goes on, and we solder once at 10 seconds, twice at 10 seconds, 3 times at 10 seconds, you can see how this area here is changing in colour with the standard material, whereas it isn't changing at all, really, with the product that's designed for that application. We get some unusual colour staining with plating as well after it's been soldered. Get some nice purple colours we've seen, or yellowing, and we've managed to prevent that from occurring. And the problem with that, obviously, is that these are blank boards, but usually you're only going to see that once the board's been soldered, when all the components are in place, and then it becomes a very expensive mistake. There's just a list of the products that we have, the application methods, the finish, and the gloss levels that we can produce. And these are some of the people that are using boards which contain that product. Here's an example of a board with our product on it and the LEDs. Now, before it says thank you, now we're going to see whether I can actually. Have we got time? About 4 minutes if I can get it to work. I have a video which was taken inside our factory. It's a promo video. None of us have been approached for voiceover work since, but it does show you some of what goes on inside the factory.
Electra Polymers is made up of a team of highly skilled specialists who, for over 30 years, have developed an international reputation as leading producers of high-quality polymer-based materials for use in the global printed circuit board and related electronics manufacturing industries. With their emphasis on innovation, R&D, quality and reliability, they have kept Electra at the forefront of PCB and electronics material development and technology.
Back in 1984, when we started, it was mainly the lab and technology driving the business, improving the quality and performance of the products. Fairly early on, though, we realised that it was all about the customer's experience and how we were going to provide good quality services and products to them. Going forward, it was all about maintaining that service to our customers and helping them meet their business and product requirements.
Electra's philosophy has established the company as forerunners in the research and development of a number of processes, now widely established throughout the industry. Electra work closely with machine manufacturers to tailor their products for optimum performance, leading on the development of spray application, 2-component aqueous photo-imageable solder masks, direct imaging materials, and the employment of nanotechnology. With Electra's ongoing investment in research, customers continue to reap the benefits in Electra's production processes, manufacturing high-quality products in the fastest, most reliable, most repeatable, and most cost-effective manner.
To create and maintain our long-term relationships with customers, it's essential we put them at the centre of everything we do. Right from the start, we get feedback from them, and From that feedback, we'd create our technologies and core competencies to meet their needs. Something we've always done and something we'll always do.
It's all about customer service, delivery and responsiveness. We know our technical service audits, our international distributor network are important for our customers. The feedback from distributors and our regular visits help us to have an understanding of latest technologies, local regulations, as well as customer and end user requirements.
Dedicated to understanding and meeting the requirements of the global PCB and electronics industries, Electra offer advice and ongoing technical support to provide the perfect solutions for their clients' needs.
Our customers have come to expect a prompt response to new requirements and product inquiries. Our skilled lab technicians and chemists follow rigorous testing processes for all new products. We also offer on-site support during the qualification period for new products, which our customers very much appreciate.
Detailed written manufacturing and test procedures are all maintained under ISO 9001 control, and quality control ensures each product, whatever the batch size, has been tested. Manufacturing details and test results, together with retained samples for every batch, are kept and archived for full traceability.
Our ISO 9001 registered quality management system controls our manufacturing processes, QC test methods and documented procedures to enable us to produce the high consistency and full traceability of product that our customers demand. A well-equipped analytical laboratory enables us to provide a rapid response to any process or product-related inquiry from our customers or end users.
Customer experience is what makes us first choice for leading manufacturers throughout the world. The success we've achieved over the years is based on integrating our customer needs with strategic planning. We know from experience that to succeed in such a competitive industry, it's vital that our development is based around our customer needs.
From high-end consumer electronics to sophisticated telecommunications, computing and aerospace applications, Electra Polymers have been delivering products and new technologies for PCB and electronics manufacturers all over the world.
At the end of the day, we work for our customers. They're the reason we exist, and if it wasn't for them, we wouldn't be celebrating our 30th anniversary this year.